talk about this comprehension module, packages, files, debugging, and exception handling. So here are the standards usage of for loop, right? You use the for and in keyword plus the range as well, and you define the start position and the end position, excluding the end position. So if it's 11, it's not really going to reach 11, right? It's going to reach until 10. And you see the append is where you add elements to your or objects to your list. There's another way to traverse in a string, right? And using the upper is upper, a built-in method. And this compression, basically you'd want to make to basically create a list in a more elegant fashion. An example of this one is instead of using the for and then append in 2 lines, you can basically break down to them in 1 line, right? Or also the initialization of the list. So to create this is you want to have a variable, and then you do want to assign the square brackets, which is a list, and inside of that you can define the first part, which is what you want to be appended, right? In this case is I times I, right? And then now your for loop is basically after that, which is for I in range, and so on and so forth. Okay, this is especially helpful when you are trying to do, let's say, a 2D list or array or 3D list array, and if you can do that in 1 line to just initialize, it will be elegant. And this one is, yes, was explained already. And this shows you just how to map the for loop, right? More or less comprehension, right? So you can see the other example that we have, which is a sequence of characters in a string, right? What if we do want to use the built-in method upper? Where do we put that, right? So you'd want to put this after your for in keyword, right? And if it's true, you basically execute the first parameter in your list comprehension. Okay. And if it's a false, right, you can just put that in towards the end, right? So an example would this one be, let's say if else, I'll show you. I can drag this up. So if you Google, right, you would see true if num is greater than 3, else false, right? The false would be afterwards. So let's say if I do have a false statement, I should put this after this one, the conditional for the if. After this one with the else keyword, and then the executable for the else, right? All right, file input and output. It's basically a way to manipulate files, right? And you usually would open up the file first, and let's say you want to grab a user input and store that to the same file, right? You do the write, and then you want to close it afterwards, right? So here are some examples that you should use. Again, to dissect this, the top part is a doc string, right? Helpful for documentation and adding comments. And this is a try, and finally, try is it will try to do it, right? And then whatever happens, it would still execute the finally to close the file. Usually you would have the try except, so if the try fails, it will go to the except, right? It's similar to if and else. However, try and accept is very helpful when we're trying to basically catch errors, right? It might not make sense in a very small use case, but once your code base becomes very large, using the accept gives you a more verbose error so that you can pinpoint which part of the code base or the logic it's failing instead of like getting a very generic error and don't know where or how to fix it. So it with there's another keyword called with, right? It's another way to use file input output operations, right? And with the with, you don't really need to use the close method, right? So it would automatically close the file after it knows that it's already outside of the with keyword block, right? So this is an example. Go ahead and try it out. And these are various operations, right? And if we've been using files ever since, so these are some of the operations that we do. An example is, let's say you have a Word document or Excel document where you click and you can read the contents, but you cannot edit it. That's only read mode, right? You can basically open and write, meaning manipulate the data, add stuff, delete stuff. That's basically writing. Okay. So we do have various file operations. We have read lines, write, read lines, and also we also have read line only, right? And let's see, if you Google as well, you would have those basic definitions. Read single line returns a list of all the lines in the file, right? And we have another built-in standard library Python called OS module, right? It gives us system level file operations with OS, and the OS has this .list dir, right? Where you can now define the path where you would look for a file name, right? And you can do your manipulations, right? Again, the path would differ if you're using Mac OS, just an FYI. OS module is also helpful with, let's say, the system time and system clear. And again, if I'm someone new learning about the module, I usually just go Python OS module, and a good habit is always to check the official documentation on how to use it and make sure you're on the correct version, right? See, okay. And I would Google again, let's say OS, let's say list dir. Okay, and it gives you more of those. And if it's not enough, look for other blogs because some of them doesn't really give good examples, and that's where you go to other blogs. Sometimes we do want to do precisions. Precisions are very helpful. For example, we have financial data where we don't want the analyst looking at it and seeing, let's say, 9 decimal places, right? It's so hard for them, and it doesn't really require them for them to do so. So you can use a precision and format the output to make it 2 decimal places, which we're always used to, right? Okay, here's an example. Again, precision is one of the somewhat of a common problem, especially when, let's say, there's a balance sheet, profit and loss statement, or loss statement, cash flow statement, where you're always missing a dollar or a cent, and yes, always try to reflect the real data, and just mention that there's some precision processing that were being shown. And another way to deal with that is, even though it is shown to the user with two decimal places. If you're hosting this information in a web app, right? Maybe let the users hover to that data and show, let's say, 9 decimal places, right? So that they can really see that it amounts to 100% of the total. Debugging, we always want to debug first. Learn how to debug. If you are a good debugger, it will come a long way instead of like using the print to check what the data type is, what the value is being held, and again, VS Code has a built-in debugger, right? Okay, debugging is also part of like the TDD approach, which is test-driven development. This is kind of the a paradigm shift from where we typically write code first and try to build tests around the code that we've written, right? And TDD, right? We do want to write the test cases first before we even write the logic of our code, right? So let's see if we can show you a TDD Python, let's see, and give you an example. Let's go with unit test, one word Python, and let's say example. Okay, I'm pulling up the official documentation, right? Unit test. Okay, let's see. All right, so let's see. So for doing unit tests, right? Unit test is basically a test in the component level, meaning the smallest component, which is, let's say, a function that you want to test, right? With the unit test, you'll be able to catch some of the errors, which is very helpful, so that the earlier the error is found and fixed, the less it is costly to the organization, right? If it found it in the later stage where you have the potential to lose customers and money, definitely it's very costly, right? So let me just open up a code base where I have an example of that one. Just move this around and put up here. So for example, let's say this one, right? So let's say I have a unit testing like this. And I have a method. Let's find a simpler method. Yeah, we can use this for now. Let's say we have a method that adds 7 to a positive number, right? Usually what we would do is something like this. We write the logic first, and then we write test cases, right? In test-driven development, you just make this an empty return, and now build the test cases. Try to think of the scenarios, and again, this can be difficult at first, but keep doing it, and also through experience, you'll kind of know what to do, right? For example, let's make this also simpler. You make a test case where the user inputs 100 and you expect 107, right? Because it does do a plus 7. So knowing those test cases, when you run this at the first time around, it will fail, which is the expected. Now, once we build all our test case, this all should fail first. And then now we want to build the logic of the code. Once we build the logic of the code, we would now run the test again and make sure we pass them, right? So now that's one of the stages. And the later stages would be is, let's say this is very unreadable to me or not really performant code, right? We refactor, and when we refactor, it should still pass all the test case, right? That helps us to check that we made changes to the code and it still is doing the same output, right? Okay, regression testing is basically running functional and non-functional testing, right? Functional testing is basically testing functional requirements that are helpful, right, to the function of the app, right? Um, for example, the one plus one, right? Does it return two, right? Non-functional, however, is those that doesn't really break if you don't do it, right? Non-functional includes security, performance, stress test, capability, those types of testing, right? So again, going back, integration testing is where you integrate this with another system or software and make sure they do work together, right? Okay, that's a segue. So going back again, debugging, right? Um, Starts with documents around variables, function names, and functions. Increasing the readability improves the debugging process, right? Because you can also do a debugging process by statically looking at it, right? And if you do have a bad naming conventions of your variable, it's basically impossible, right? An example, if I don't even know what the A or double A, triple A means, right? But if let's say they mention that as n size, I know this is the size of the variable n, right? And what is 100? I don't know. But this one, I know this is the max number, right? What is compute? Computing for what? I don't know. But this one shows me it's computing for average, right? Having good naming really helps debugging. Okay, debugging is defensive programming. Requires study leading up to erroneous states or errors, right? And again, most of the time it's hard because in the real world, most of the time you do end up inheriting somebody else's code, and you really have to learn the code base, and you would need to know where to look and where to debug as well. Okay, test 3 levels of testing. Testing approaches. Black box is basically you don't know what's inside, right? And you just test. White box is you know all the possible things or paths and you test it, right? And again, like you would have visualizers as well to make sure code coverage, right? When you say code coverage, let's say you have 10 lines of code and you have an if else statement, right? If greater than 10, print true. If less than 10, or else, print false, right? If you only have a test case, let's say for the input of 11, your code coverage would not be 100% because you only reach the first if block, which is greater than 10. So you might want to add another test case where it's less than 10 so that you would also go to the path of the else statement, and that would give you 100% code coverage. Invalid operation raised, but instead there are also exceptions to the normal operation. So the main difference between raise and try is the crash versus complete, right? And the rest of execution, right? Sometimes crash is inevitable, so at least we say something before we die, right? And again, this is going back to having a more verbose or more detailed error output before even crashing or erroring, right? Instead of just a generic error. Try except block, right? We mentioned that try would try to execute the code. If there's an error, it will go to exception and it will catch it, right? And else, if there's no exception, run this code. Finally, would regardless of whether it goes to the except or else, right? It will still execute that finally block. So exception handling, good practice for running up application, avoids crash. So again, avoids crash because it will grab that, and instead of like, oh, error, let's say you already expect that error, you may want to grab this error and maybe do something else, right? As you can see, another example, file not found error, import error, type error, right? So that helps us instead of like, oh, this is integer error. We just don't know what happened to the integer. But if we catch that, right, and have a more verbose example, oh, you used a zero. So you can basically do a catch for that zero. If someone divides by zero, you can throw this zero division error instead of just, well, it's error, right? So here are some examples you can try, right? And try except block. Multiple exception is possible as well. Okay, assertions. In unit tests, what I've shown you earlier, let's say if you still have that, you have different types of assertion, right? You can assert equal with two parameters. This would return 107, which is the actual, and this is the expected, which is the 107, right? Then see assert positive value, assertion, true false expression, checking types. Let's say I want to make sure that the input is integer instead of like a string, right? The values, the empty values, if there's empty, right? And other debugging tools, traceback. Let's see, assert, exceptions, traceback. So traceback is helpful for tracing information in Python programs, right? You basically want to wrap your functions with it. Different types of logging information. Import logging, right? So it now helps you with logging.debug, info, warning, error, critical, right? Start the program, debug, debug. Okay, logging is basically a better way instead of like just saying a print, right? And this is the end of the lecture. Any use case that you think of, let me know. Let's work on your simple programs, Python programs, and let's see what good things we can come out of it. Okay, thank you, and this is week 3.